In the figure above, tan B equals 3/4. If BC equals 15 and DA equals 4, what is the length of DE? So this is the segment that we are interested in. So keeping in line with what we've been seeing, that there's always a concept behind every question, this one may be a combination of several, right triangles, and similarity, and stuff like that. So let's just try to tackle this. So we're given the tangent of angle B. Here's angle B right here. And if you focus on the big triangle, triangle ABC, we can try to come up with some numbers. We're also told that BC, this length here, is 15. So keep in mind that tangent is defined as the side that is opposite from the angle given over adjacent, the side that's adjacent to it. So if focusing on the big triangle and looking at B, AC would be the one that's opposite, and adjacent to angle B, looking at the big triangle again, is AB. However, that doesn't seem to make sense. If BC is 15, then how can opposite be 3/4? So let's try to make a smaller triangle here. And we're going to say, based on the tangent given, tangent of angle B, let's call this angle B right here. It looks like opposite from angle B is a 3. Adjacent to angle B is a 4. So what would this missing side be? If you've done the math, you will see that this right here is 5. In fact, you may just remember the 3, 4, 5 triangle, which would be really, really great. But you notice that this side, this 5, is now changed, and it became a 15. That's BC. That's the hypotenuse, which means it's this triangle here, the big one, is a 3, 4, 5 triangle, but it looks like every side will have to be multiplied by a factor of 3. 5 times 3 is what gave us the 15. 3 times 3, so we know that this side really should be a 9. And this side here, 4 times 3, should really be a 12. That means AC right here is really 9, and means BA or AB is 12. We were also given the length of DA right here is 4, so we know that this is 4 centimeters. Now the question was, find the length of DE, and now enter the idea of similar triangles. So you notice that we have 2 triangles here. We have triangle BDE, and we know that it's similar to triangle BAC. All we need to do is establish what sides are similar to each other. So let's match the sides. We know that once again, for the big triangle, the whole length is 12, which means if that's 12 and we were given this as 4, that makes this BD is 8. So we can say that BD for the small one corresponds to BA for the big one. So we can set that as a fraction. BD corresponds to BA. So we're doing the smaller one over the bigger one. And since we're interested in DE, we have to feature those sides. So smaller one, DE, corresponds to AC on the big one. And now we plug in the numbers. BD is 8 over AB, which is 12, equals DE, which we're looking for, over AC, which is 9. And then we're just going to cross multiply here to solve for DE. And we end up with 12 DE equals 72. Divide both sides by 12. And you find that the missing side, DE, ends up being 6. So DE equals 6. And it's a free response, so please enter that. And that's it.